Hey guys, this is Algebra Lesson 5, Order of Operations with Exponents. And I've got a little PEMDAS joke here for you on the screen. Little addition sign saying after you, and parentheses and exponents and division are of course going first. So that's really funny. Okay, good. Let's keep going. All right, you have some review problems on your notes in front of you. I would like you to go ahead and pause the video and do those problems right now. All right, hopefully you had a chance to finish those. Let's go ahead and check your work. So that first one, you have 40 minus 5 times 2 minus 3. So we don't have any parentheses or exponents in this problem. So you're going to go first in the multiplication and solve it first. So 5 times 2 is 10, so now you have 40 minus 10 minus 3. Then we're just solving from left to right. And we have 30 minus 3, 40 minus 10, of course, equaled 30. And then our answer is 27. Next one, 54 divided by 3 times 3 plus 5. No parentheses or exponents, but we have division and multiplication. So we're going to work from left to right. So first we'll do 54 divided by 3, which is 18. Now we have 18 times 3 plus 5. The next we'll do 18 times 3, which is 54 plus 5. And our answer is 59. Okay, now I'm sure you guys are probably freaking out with all of these crazy parentheses on this problem. This is just a fun problem. So obviously we have parentheses, so we need to look at the parentheses that are furthest inside, if that makes sense. And so the first thing we're going to solve is right here. So you know what, actually I'm going to do this one with my pen because I want you to see exactly what I'm doing. Okay, so these different parentheses are just to show you what goes with what. So we're going to just use the same parentheses as we solve them, and you'll see what I mean in a second here. Okay, so first we're going to solve inside this set of parentheses because that's the innermost set. Oops, where did it just go? Okay, got them back. So 85 plus 19 is 204. Now I'm going to keep my parentheses here just to keep track of what I'm doing. So now I have 204 divided by 12 plus 13. Write out the rest of my problem here. Okay, now I'm going to do this set of parentheses. Oops, I forgot to write the 13 right there. Okay, 204 divided by 12 is 17. So now I've got 17 plus 13 in this set of parentheses right here. Okay, now I'm going to solve within this parentheses. Okay, 17 plus 13 is 30. Now I can take those away. I can take each parentheses away as I solve in them, and I'm left with only a number and no operations. So now I've got 30 divided by 2 plus 66 divided by 9. Okay, now I've got two operations within this set of parentheses, so I'm going to solve them according to order of operations. So 15 divided by 2 is 15. Oh, we're getting close, guys. 15 plus 66 is 81. Drop those parentheses because now I don't have any more operations to do in them. So now I'm down to 81 divided by 9, and my answer is 9. Okay, so today you are going to be introduced to another math convention, exponents. Exponents are a way of writing repeated multiplication. I don't know if you remember, but on the first day of algebra, or well, maybe it was the first day of PEMDAS, I think I posed a question to you and I asked you if you could come up with a theory for why we have order of operations. And I never answered that, but really the answer is multiplication is higher than addition because multiplication is repeated addition. Division, of course, is the inverse of multiplication, so it's on the same level as multiplication. Exponents are higher than multiplication because exponents are repeated multiplication. So you would do exponents before multiplication because exponents are repeated multiplication. You would do multiplication before addition because multiplication is repeated addition. And then, of course, division and subtraction are just inverses of those other operations, and so they're just kind of on the same level. But, all right, got that out of the way. So right now we're going to write an equation for its volume. Hopefully you remember that volume equals length times width times height. So we've got our formula there. Now we're going to substitute in the 4 because this is a cube. Looks like that. That measures 4 centimeters on all sides. There we go. Okay, so if we're going to write an equation for its volume, we just did it, and we would end up, if we multiply that out, we'd get 16 times 4. If we solved it, we'd get 64 centimeters cubed. Now we're going to write an expression for the volume of the side of a cube that measures s centimeters. So again, here's what that looks like. It measures s centimeters here, s centimeters there, and s centimeters there. Let's see what that looks like. Volume is going to equal still, you know what, I should have my length times width times height up there. But now it's going to equal s centimeters on all sides. So here's the deal. We don't typically write s times s times s. We would write s to the 3rd centimeters cubed. We also don't write s, like, I know I've told you that the variables and the coefficients next to each other, or even two variables next to each other, mean multiplication. So this right here does mean multiplication. But we don't write that. Instead, we write s to the 3rd centimeters cubed. The superscript 3 in this expression is called an exponent. What it does not mean, let's go back for a second. What it does not mean is 3 times s. No, sir. That is a different problem. This is written as a little number to the right and slightly above the variable or the number that we are multiplying, and it's called an exponent. It means something times itself a certain number of times. All right. Problem. We have a box with a square base, 4 centimeters on the side. What is the area of the base? So here's our box, and let's pretend we're looking at the base, and just for illustrative purposes, let's pretend the top is the base because it's kind of hard to see the bottom. So we want to ask ourselves, what's the area of the side? Well, we already know it measures 4 centimeters on all measurements. So area is going to equal length times width. Let's substitute in our values. Area equals 4 times 4. And then let's solve it. Area is going to equal 16 centimeters squared. Now, let's write an equation for the volume of the box if its height is 5 centimeters. So remember that volume equals length times width times height. So now our box looks like this. The base is 4 centimeters by 4 centimeters, but the height is 5. Okay, so let's substitute in some values. The volume equals 4 times 4 times 5. If we solve that, volume equals 16 times 5, which equals 80 centimeters cubed. Why am I walking you through area first and then volume? I want to show you something cool here before we go any further. Volume equals length times width times height. Hopefully you recognize that this right here is area. So cool little side note, volume equals area times height. If you know the area of a box or a prism, a rectangular prism, you can multiply its area times its height and get its volume. So, haha, I think that's awesome. All right, now let's write an expression for the area of the base of the box if the side of the base is b centimeters. So now here's our box again, and we've got b here, and we've got b here. Area is still length times width, so now we're going to substitute b in for both the length times width. Okay, well here's where exponents come into play. B times b is much better written as b to the second power centimeters squared. You should practice saying that right now. Go ahead and pause the video. This is some math language that you need to know. That's called b to the second power, or b times b. All right, now let's write an equation for the volume of the box if the height is 5 centimeters. So let's draw our box again. And remember, our base was b, and now our height is 5 centimeters. So let's start with our volume equation. Volume equals length times width times height. And let's substitute in our b value for both the length and the width, and substitute 5 in for height. So volume equals b times 5. Now here's how we're going to write this. Let me take that away for a second. If we just go ahead and do this second step, right? We know that b times b is b squared times 5, right? Well, we don't write it like that, because remember how we've been talking about with algebra notation, we write the coefficient before the variable. So we're going to write volume equals 5 b squared centimeters cubed. Make sure you have that written down correctly on your notes, please. All right, a little more math language here. We're going to expand 6 to the third power. 6 to the third power looks like 6 times 6 times 6. It's 6 times itself 3 times. That's what that means. Now let's solve 6 to the first power. Well, 6 to the first power means 6 times itself, but only one time. So what's 6 only one time? It's just 6. So your answer there is 6. Okay, now we're going to do 6 to the fifth power. Go ahead and pause the video and see if you can write this and then check your work. All right, you should have written 6 times 6 times 6 times 6 times 6. It's 6 times itself 5 times. Okay, let's go the other way now. Now we're going to write 7 times 7 times 7 times 7 as an exponent. How many times itself are we timesing 7 by? We're multiplying it times itself 4 times, so it's called 7 to the 4th power. You always need to make sure your exponent, oh, that's a little flub. You need to make sure that your exponent is to the right, slightly above, and smaller than whatever number it's referring to. All right, now let's write a variable as an exponent. N times n is going to equal n to the second power. All right, now we're going to expand and solve. So if we expand 3 to the second power, it's going to look like 3 times 3. And then if we solve it, it's going to look like 9. Okay, let's do this next one. We're going to expand and solve 5 to the 4th power. It's going to look like 5 times 5 times 5 times 5. Did I say it too many times there? I hope not. Now we have 25 times 25, which if we solve that, it's going to equal 625. If you're struggling with how I got there, go ahead and calculate that over to the side. Go ahead and do the multi-digit multiplication and make sure that you come up with the same thing that I did. Okay, I'm at my 15-minute limit for Screencast-O-Matic here, you guys. So I'm going to stop this video and I'm going to finish it in a part 2 on YouTube.